In our last class, we have studied about the concept of statistics, its advantages, disadvantages, types, functions. In this class, we are going to study about the data and how do we present it. So what is data? Data is any units of information, mostly numeric, that is collected through observation. Or in a more technical sense, we can say that data is a set of variables. It can be qualitative as well as quantitative, that is collected from any object or any person. Or you can say that data is number and words which can be analyzed for the future use. But if this is data, then what is information? Information is a piece of data which is collected, analyzed, presented in some meaningful context. We can divide the data into two types. One is qualitative data, another one is quantitative data. Data can be anything. For qualitative data, it can be the name of your employees, it can be the name of the products, or it can be even simple name of students. For quantitative data, it can be your sales figure of last 5 years, your age, your height of 10 students, or it can be anything which can be presented into numbers. So let's start with the quantitative data. What is quantitative data? Quantitative data is a data which answers the question how much, how often and how many. We can further divide this quantitative data into two. One is interval data and the another one is ratio data. So let's talk about the interval data. Interval data are measured and ordered with the nearest item, but have no meaningful zero, and it can be negative also. For example, temperature in degree centigrade, dates like 1947, 2022, time interval like 12 p.m., 6 p.m., 9 p.m. Next one is ratio scale. Ratio data is fundamentally the same as interval data. Aside from zero means none. It means here 0 has some value. For example, age can be from 0 year to 100 plus, distance from 0 to 20 kilometers, and time interval from 0 minutes to 20 minutes. Now, what is qualitative data? Qualitative data can answer questions like how this has happened and why this has happened. Qualitative data can't be in numbers, it can't be measured. Qualitative data consists of words, pictures, symbols and not numbers. Example of qualitative data can be anything like color of the sea, your favorite holiday destination, or a simple names or name of the products, anything. Qualitative data is further divided into two types, nominal data and ordinal data. Nominal data is used just for labeling variables without any type of quantitative value. For example, gender. It can be women or men. It can be marital status like married, single or widowed. So the next is ordinal data. Ordinal data shows where a number is in order. It can be first, second and third person in a competition, or when a company asks its customer to rate the sales experience on a scale of 1 to 10. Or it can be economic status like low, medium and high. So let's understand this nominal data, ordinal data, ratio data and scale data with the help of an example. Suppose I have 3 apples. Apple 1 is of red color, apple 2 is of yellow color and apple 3 is of green color. Now this red, yellow and green is my nominal data. Now I say that apple 1 is sweet in taste, apple 2 is medium in taste and apple 3 is sour in taste. So this sweet, medium and sour, because I am comparing the things, I am ordering the things, so this is my ordinal data. Apple 1 is harvested on 4th September. Apple 2 was harvested on 14th September and Apple 3 was harvested on 30th September. So this 4th September, 14th September and 30th September is my interval data. Apple 1, it was of 50 gram, Apple 2 was of 100 gram and Apple 3 was of 150 gram. So this 50 gram, 100 gram and 150 gram, these are my ratio data. After deciding type of data, now if I collect the data in this way, is it presentable? Are you able to read it? No, obviously not. And if I collect my data in this way or presented my data in this way, now isn't it readable? Isn't it organized and well presented? This is how all our statistical department, economics department and census department present their data. So presentation of data is equally important as collection of data. After all, everything that's pleasing to our eyes never fails to grab our attention. Presentation of data refers to an exhibition or putting up data in an attractive and useful manner such that it can be easily interpreted. Presentation of data can be done in tabular form as well as graphical form. Tabular form. Systematic organization of data in rows and columns is called tabular presentation. We all used to see tables and numbers in our day-to-day life. So if we see the parts of the table, let's see. First is table number. Each table has specific table number for ease of access and locating. Like here it is table number 5. It is readily mentioned anywhere which serves as a reference and leads directly to the data mentioned in that particular table. Second is title. A table must contain a title that clearly tells the readers about the table, like here it is youth activities. Next one is column header, which is also called caption. A column header is the title of the column in the data table. Next, we have row classifier, which is also called stub. These are the title of the rows in a table. The stub display information about the data that is contained in the rows. Next comes body or field of the table. The body of the table is the content of the table in its entirety. Each item in a body is known as cell. Next comes source. So what is source? So when you use your data obtained from a secondary source, this source has to be mentioned in the footnote of the table. So now let's talk about the graphical presentation. Graphical presentation is a presentation which you present the things or present the data in the form of graphs. It can be histogram, it can be frequency table, it can be pie chart, line graph, line plot, whisker and box plot. So let's understand one by one. So the first one is bar graphs. Bar graphs is used to display the category of data. Bar graphs are the pictorial representation of data in the form of vertical or horizontal rectangular bars where the length of the bars are proportionate to the measure of data. Bar graphs can be of 4 types. First is vertical bar graph. When the group data is represented vertically in a graph or a chart with the help of bars, that is vertical bar graph. The second is horizontal bar graphs. When the group data are represented horizontally in a chart with the help of bars, that is horizontal bar graphs. After horizontal and vertical bar graphs, we have clustered bar graph also, which is used to represent the discrete value for more than one object that shares the same category. In this type of bar chart, the total number of instances are combined into a single chart. The next chart is stacked bar graph. The stacked bar graph is also called the composite bar chart, which divides the aggregate into different parts. In this type of bar graph, each part can be represented with a color, which helps to easily identify the different categories. So next is histogram. A histogram is a graphical representation that organizes a group of data points into user-specified ranges. Both histograms and bar charts provide a visual displaying using columns, and people often get confused in that. More technically, a histogram represents the frequency of numerical data set. On the other hand, a bar graph typically represents a graphically comparison of discrete or categorical variables. So next is frequency table. Frequency table displays the frequency of various outcomes of sample. Each entry in a table contains the frequency or count of the occurrence of the values within a particular group or interval. So the next one is pie chart. This is one of the most attractive form of graphical presentation, which is divided into slices to illustrate numerical proportion in a chart. The arc length of each slice, its central angle, area is proportional to the quantity it represents. The next one is line graph. We plot line graphs using several points connected by straight lines. The line graph comprises of two axes, x-axis and y-axis. The horizontal axis is known as x-axis and the vertical axis is known as y-axis. So the next one is stem and leaf plot. A stem and leaf plot is a way to plot data where the data is split into stems, that is the largest digit, and leaves, that is the smallest digits. The stem and leaf plot is used like a histogram. It allows you to compare data. Stem and leaf plots are used to display the quantitative data, that is numbers, for small data sets of no more than 40 or 50 points. They display the exact values of each data point. These plots are useful for visualizing frequency distribution in the data sets. So the next is box and whisker plots. It is one of the most effective and easy to read as they can summarize data from multiple sources and display the results in a single graph. Box and whisker plots allow for comparison of data from different categories for easier, more effective decision making. It contains 5 values. One is minimum value, the smallest value in the data set. Second is second quartile, the value below which the lower 25% of data is there. Third is median, which divide the data into 2 parts. Fourth is third quartile, the value above which upper 25% of the data are contained. And the last one is maximum value. The largest value in the data set is maximum value. So this is all about today's class. If you have any questions, you can mail me at sanjoli@taxila.in. I'm sharing some questions. Try to solve them and mail it to me. Don't forget to attend next class where we have a brief introduction of SPSS and we will see how we can make these graphs on SPSS very easily. Don't forget to download SPSS trial version in your laptops before attending the next class. The link is shared in the description below.